Now, this is the second video on the operational amplifier, and we're going to talk about feedback. Feedback is when you feed the output or part or all of the output back again to the input, as you can see from there. In the case of an operational amplifier where we're talking about open loop gain, now it's going to be closed loop gain. To get this closed loop gain, we find that we use the same formula that we had. V out is equal to the open loop gain times V in. Remember, we're getting our V in by comparing what is getting in through the non-inverting and what is getting in through the inverting. Now, since what's getting in through the inverting is now a fraction of V out again, so it's adding to our V in. So we're going to get V in plus that beta V out, where beta is that fraction that we're talking about. So V out brackets 1 minus that should equal the open loop gain times V in. That's just rearranging. Then V out over V in is the expression for the gain. So it's going to give you A naught over 1 minus A naught beta. So that will be the expression for the new gain. Negative feedback. This is when part or all of the output is fed back to the inverting terminal, resulting in a reduced output voltage. Okay, so the gain, the output itself is 180 degrees out of phase with the input, so this results in a smaller voltage output. Although negative feedback may seem to make the process of amplification rather fruitless, it is more important for one, operating stability, distortion, so it reduces distortion of the output, and it also increases the bandwidth. Bandwidth is the range of frequencies that can be amplified by the same amount, so that is why it is very desirable. This leads us to talk about the inverting amplifier. An inverting amplifier has input voltage fed into the inverting terminal, so that becomes the inverting amplifier. Now, it is negative feedback again because the output is being fed back to the inverting terminal. So it's an inverting amplifier and it is negative feedback again. So the initial waveform looks like this. It's a sine wave. So the output wave now is reflected about the x-axis, so it is 180 degrees out of phase with that, but it is larger. The virtual earth approximation. Remember, we said that if there's a difference between V plus and V minus, the output voltage will saturate to the supply voltages here. So in order for us to avoid saturation, we should have these both approximately the same. Now, the non-inverting terminal has been connected directly to earth, as you can see, so which means we should have a point where on the inverting side where the potential is also approximately 0, so that there's no saturation. So this point P is called the virtual earth. The input impedance of the operational amplifier itself is very large, so there's no current in either the non-inverting or the inverting inputs. This means that the current from or to the signal source must go to or from the output. As you can see in the arrow, we have got the current going this way. It cannot draw current because there's a very high input impedance or resistance there. So it goes through there. So this forms a potential divider. Or it can go from the output, right, like that. So that's how you get. Now, this current in the input resistance is equal to current in the feedback resistance, which is the output. So current, the definition for current, PD over resistance. So it will be PD in Rin over Rin to give you PD across RF over RF. Okay, now the potential at P is 0, so which means coming from the input, we can now say V in minus 0. So that's at P. Over R in is equal, now coming from P to the output, now it's 0 minus V out over RF. Overall, if you work this out, this one becomes minus V out over RF, this one is V in over R in. So that's why you end up with a negative sign there. So that's the expression for the gain in an inverting amplifier. This is an example which you should work out. Just tell me the answers in the comments and then I will help you out. I'll just give you some clues or some hints on how to do it. The gain of an inverting amplifier is 25. The supply voltage is plus or minus 9 volts. And the non-inverting input is at earth potential. Calculate the output potential of the amplifier circuit for an input voltage at the inverting input of that. So V in is 40 millivolts, and then V in the gain is 25. To get V out, you say gain times V in. So it will be 40 millivolts times 25, which gives you, but then since this is an inverting amplifier, your output must come out negative. And this one, output must come out positive, and then this one, output must come out positive again. Now, where you get the V out greater than 9 volts, just know that it saturates at 9 volts. You can't get a value which is above the 9 volts which is being supplied. So just work it out and then let me know in the comments. Non-inverting amplifier. It's a non-inverting amplifier because V in is being fed to the non-inverting input. So V in is being fed to the non-inverting, so it becomes a non-inverting amplifier. Feedback is always to the inverting amplifier terminal rather. So feedback is always to the inverting terminal, and it is in the form of this potential divider. So we say R1 over R1 plus RF times V out gives you what is getting in through there. Now, in order for our operation amplifier not to saturate, this value of the voltage R1 over R1 plus RF times V out should equal V in to avoid saturation. So we found our V in. So for the gain, it's V out over V in, which is going to be 1 plus RF over R in. Okay. I hope that makes sense. This is an example on the non-inverting amplifier. So if RF is equal to 7,200, arise that, then plus or minus Vs is 9 volts, or Vs is plus or minus 9 volts. Calculate the gain of the amplifier. Calculate the maximum input such that, so gain is equal to 1 plus RF over Rin. So 1 plus 7,200 over 800 should get your output. So the gain rather. And then it says calculate the maximum input potential such that the amplifier does not saturate. So we are now taking this as our output voltage, and our gain we found to be, from that calculation, find it to be 10. So you just make V, just find V in. Okay, so V in will be equal to V out over the gain, which is the gain that we've calculated divided by, so V out, which is 9 volts, because that's the maximum voltage before saturation. I think I'm going to end here my video, and then I'll talk about output transducers in the next video.